Today is the 13th of June 2024. Okay, and we are going to look at submerging a sphere into a cylindrical container. Okay, so um, let me start with this and then I will explain what that means. So please subscribe, share, like, follow. Okay, please follow my notes slash scripts. Okay, you see that in the comment section. Please do follow my notes slash script. It will be a lot helpful for you. And please, if the account is not yours, ask permission or open your own account. Okay, I'll appreciate it a lot that you subscribe and do all I'm telling you, but please be cautious. Don't uh, put somebody else in trouble or misuse people's account, please. Uh, Beware of scammers, okay? They are everywhere. Please beware of them. Now, in our recap, watch last video for recap. And then what did we do? We found the radius of a sphere given surface area. So I've explained to you that assuming you've been given the volume of the sphere, you need the volume of the sphere and you've been asked to find the radius, then you need the volume of the sphere uh, formula. Okay, but assuming you've been given the surface area, which we've learned how to do, and we've learned how to use the formula, and I've shown you how to put in the right this and do the calculation. So assuming you've been given the surface area and you want the radius, you don't go and use the volume of the sphere because you don't have the volume. Okay, you have the surface area, so you use the surface area formula and then you find the radius. Okay, now the radius is the length, so you always choose the positive, and then if you are not given the units, you put the right unit you've been given. So we've done that. Watch the last video for recap. Okay, now we've been looking at the circle theorem. So we've for the last I think there are 8 of them at this level. So we've been looking at that, and I've brought each of them. So I brought the last one yesterday, alternate segment theorem. Okay, that was the question we had when they were asked to write the name, the exact name of the circle theorem we use. Okay, but even now, even though I know how to use it, now I don't think I'm going to forget alternate segment theory. Neither should you. Okay, neither should you. So that in case a question come like that, you just write it out. But please go around and watch. We've done the circle theorem as on its own, but as you are watching the video, watch the status that we did as well and try and see if you can. And it's because giving a reason is simple. I can always give you a reason that this angle equals this angle, so that's why my answer is this. But assuming they ask you the name, then like what is it, a tangent? Is it a circumference? Those you can easily remember. But this kind of names at times is difficult. But I think now I won't forget, and you also not forget. It will be at the top of our head. Okay, it's just 1 mark. So yes, but that 1 mark can stop you from going back for a reset, which is good because whether you get the lower end of a C or the upper end of an A star is all classed as a Gcse. Okay, and some people they all they want is a C. Okay, you can say everything. It's like that is what they feel they can get. So that's what they fight for. Okay, and some people too, maybe they want A star but they got A because they mixed out on 1 mark. Okay, so at the end of the day, it depends on what everybody wants. But if everybody can get between A star and a C, then it means we can have um, our the future generation moving forward to achieving their goals. Okay, because with a C, you can still go to uni, you can still do that. Okay, you can get an access course, use that and go to uni. So it's not like, oh, you got a C, so you can't. But with a D, unfortunately, you can't. So that's why on this platform, I try to encourage you and then show you how you can get marks. Okay, so that you can just try and not lose marks. Okay, there are some marks that when you lose, it's painful because you could have gotten the marks as well. Okay, so today let's do some mental maths with money. Now, this is money, so you have to leave your answer in 2 decimal place. So if you are writing £10, you can just write the whole number. But if you are writing £10 and 1 pence, you can write 10.1. Okay, you have to write 10.01. If you're writing £10 and 10 pence, you have to write 10.10 because in real life, money is always measured in 2 decimal places. Okay, so this is what I'll say before I start. So look, this is non-calculator. If I spend £1.50 on fruits and £2.60 on vegetables, how much will be altogether? This is easy to do. Okay, so £1.50, £2.60. Okay, so you can have £1.50, £2.50. That will be £4, but it's £2.60, so that'll be £4.10. Again, money. So remember the pound sign or the dollar sign or wherever you are. Okay, to 2 decimal place. Okay, sorry. Now, a bottle of lemonade will cost £1.15. I need 9 bottles. How much will it cost altogether? So this is 1 bottle. So you need to buy 9. Okay. Now, if you look at this, 10 of this, okay, will give you £10.15. But you need one less. So I'll just subtract £1.15 from this one. Then I have 9. So that's what I've done. £10.15 for 9 bottles, £1.15 for one bottle. Okay, because I'm going to the shop to buy 9. If I subtract £10.15, 10 bottles minus £1.15, one bottle, then I'll pay £9. Okay, so assuming I gave out £10, then I'm expecting a change of £1. Again, it's money. So 9.00 to decimal place. And then I have to bring the currency sign, whether it's euros or dollars, or which part of the country I am, France or wherever. You put the UK uses a pound sign. Okay. So that is the stuff I have with you today. Now, today we are submerging a sphere into cylinders. Sadly, my cylinder shape is the same cylinder, the same size, but I had to reduce the size because of shape, because there are 2 holes here, and I didn't want to go extra. Okay, so I could have brought this a bit here, so that's why, but it's the same cylinder. So assuming you can do this as a physics experiment. Okay, so the people who are doing higher science, who are doing physics, chemistry, math, this can be very helpful. So after the experiment, so now you have this cylinder here, or you have this beaker here, and the diameter is 10 centimeters. And then the question here says, I'm just trying to explain what we do today. And then you have another sphere here. Okay. Now, if you put the sphere in the water, okay, it's going to increase the height. So you might have it here. First, the water is here, and then you drop your sphere in. That is the displaced height. Okay, so you can use this in a physics experiment, and then you have to find the height. Maybe you might do it like 3 or 4 times, and then they'll ask you to plot a graph, find the constant, do calculations. We used to do it when we were in school. Okay, so I remember a lot because I have the science base as well. I can also teach science. It's just that because I majored in maths, maths is more better for me. Okay, so this is one of the things I want to share with you today, but this is like for the higher students. Okay, but if you're a foundation student and you want to change to higher, you can. If you think you are in year 7 or year 8, you still have up to year 9 to learn these things. Okay, because some of these things they might not teach you till year 9 or year 10 when you've selected your subjects. Okay, because you might need this. So here, what do? So we are assuming the diagram is not this about. We are assuming this beaker is 10 centimeters in diameter. That beaker is 10 centimeters. And today we are finding this height here. Okay, please look at it carefully. Okay, because I've just drawn this one diagram, and then we'll go through the examples I have. So now the first one, okay, the diameter of the a container of the sphere, this sphere here, yeah, that has been put in this cylinder to raise the uh, liquid or water level here is 10 centimeters. Okay, so half of the diameter is 10 centimeters, so half is the radius, so which will be 5 centimeters. This is what we need to use. Okay, now the cylinder itself is 10 centimeters. I told you it's the same beaker, but it's because of space, that's why I had to redraw it smaller, and it's not to scale. So the diameter now here is 10 centimeters. Okay, so now we need to use, they said we should find this, we are finding this height from here to here, because if you put the sphere in here, the water level is going to rise, and that is the rise, that the h that we need to find. So what do we know? We found the volume of the sphere. I showed you how to find the volume of the sphere in one of the videos. The volume of the sphere is 4 over 3 pi r squared. The sphere you drop into the liquid container. Now this is the volume of the cylinder. Okay, pi r squared. So if you put this sphere in the cylinder, this is the volume you are going to get. Okay, and that is the height that it will rise, and this is the height that we want. So if you equate the volume of the sphere to the volume of the cylinder, then you make h the subject. Okay, so remember the volume of the sphere is 4 over 3 pi r cubed, and you equate it to the volume of the cylinder, pi r squared h. Okay, now the volume of the radius of the cylinder here, we've been given the diameter, so we have it. So the radius will be 5. So in here, f4 over 3 pi is a constant. So all we need to do is the 5 cube. Pi r squared is also a constant. Okay, no, pi is a constant here. But the volume of the cylinder here is 10 centimeters, and we need the radius, so that will be a 5. Okay, so that will be 5 here. No, that will be 10 here. Okay, because the volume here is the diameter is 20, so half of this is 10 centimeters. So let me say it again so that I don't confuse you. That is the sphere part, 4 over 3 pi r cubed. The sphere has a diameter of 10 centimeters. So the radius will be half of that. So we need to cube that. The cylinder, this is the volume of the cylinder part. Because if we put the sphere in the cylinder, there'll be a displacement. The water level will rise. And we want the h, the rise. But the cylinder has a diameter of 20, okay, 20 centimeters. So we want the radius, we don't want the diameter. So that is also half. So pi 10 squared, and then h. This is the h we want, that h here in this diagram. I hope I'm clear now. So we've equated the two formulas, and we can now find h. Okay, pi on both sides will cancel out. Now we are left here in this question 4 over 3 pi 5 cube and then 10 squared h. Okay, 10 squared is 100 h. Okay, so now h will be 10, 100 is multiplying here, so if it comes to this side, it will come and divide. So we just repeat the whole of this and divide by 100, which I've done here. Okay, so we can cancel out, or we can use the calculator. So if you cancel out, you get 1.7 centimeters to 1 decimal place. Remember, you are finding the rise, the height, this height here, when you put the sphere in. Okay, so what I said cancel out, 25 1 and then 100 4 times. This 4 can take care of this 4, so you have 5 over 3 left. So 5 over 3 on the calculator, okay, you have 1.7, okay, centimeters to 1 decimal place. So the same example that we have here, okay, so I didn't redraw it again because it's the same thing. You have a beaker or a cylinder, you drop a sphere, that part is the volume of the sphere, and that part is the volume of the cylinder. Okay, and that contains the h. This is the h we are finding. We are finding the rise of the liquid level or the rise of the water level. Okay, now the question we are going to look at now, okay, is similar to what we've done. If we've been given the radius of the sphere, we use it. But if we've been given the diameter, then we have to halve it. Okay, so this is 3, because if the diameter is 6, then the radius will be 3 centimeters of this sphere ball that we are putting into the liquid. Now the beaker that we are using, the cylindrical beaker, it has a diameter of 20, so we have to have that as well, because in the formula we have radius. Okay, so now we need to have this 20 to get 10 centimeters. Okay, now so this part here is the volume of the sphere, and that part here is the volume of the cylinder, and is this h we want to find, the rise in the water level. Okay, I think if you're in year 10, maybe you've done an experiment and you've used these two formulas, okay, to find your h, and then maybe you plot a graph of maybe you put in this sphere radius, okay, get different height, and then maybe you are asked to plot a graph, and then they might ask you questions after that. Okay, you can get that in your physics practicals. So now you have 4 over 3 pi. R here is 3 because we're giving the diameter here as 6. Okay, so we have that. So it's 3 cubed. And then pi R here for the cylinder is 10 centimeters squared h. The pi's will cancel out. So H now becomes 36 over 100. Or in decimal, it becomes 0.36 centimeters. Okay, to two decimal places, or 0.4 to one decimal place. Okay, now, so if you have in a physics experiment, you can be asked to do that. Okay, the beaker will be the same, but the sphere ball might have different radius. So they might ask you to plot a graph of uh, the radius of a sphere and the height, the rising height. Okay, and maybe after that experience, they might ask you questions after that. Okay, you perform the experiment with maybe 5 or 6 balls, spheres, and keeping the beaker as a constant. You can have that. Okay, so that is one of the things. And then you use the rise in the water level. Because the rise in the water level, if the diameter is different and the cylinders have the same radius, then you can use the rise in water level and the sphere radius, plot a graph, and then you see the pattern, and then the questions that follow you answer. Now this question again, okay, now the sphere ball is 12 centimeters in diameter, so the radius will be 6 centimeters. The beaker here is 30 centimeters in diameter, so the radius you need is 15 centimeters. Note everything is in centimeters. Okay, so your H will also be, the rise will also be centimeters. Okay, so basically we are doing this mathematically, but in the lab you might have to measure the height. Okay, beakers have measurement. So if you put in the ball, first before you put in the ball, you would take the original level of the liquid, the solvent, okay, and then if it's water, you will know that you are using water, or if it's a different liquid they've given you, they might just want to know the density or something. Okay, and then you drop the ball in, and then you measure the height in the lab, and then you use that. But I'm showing you the mathematical one. Okay, so that is uh, the sphere volume, and that is the cylinder volume. Okay, so as I've just told you, our next question, the sphere is 12 centimeters in diameter, so half of the radius is 6. The beaker is 15 centimeter, 30 in diameter, so half of 30 is 15. Now this is the H we want. Okay, so the pi's will cancel out, so you have 4 over 3. 6 cubed on the calculator is 216, and the 15 squared is 225, and then H. So making H the subject, okay, you divide both sides by 225, and then you get an answer of 1.28 centimeters. This is to two decimal places. So this will be your displaced volume H. Okay, which in your experiment you'll be asked to measure, and they do it several times and use it to plot a graph. Okay, So if you know how to do this, you can also do the mathematical bit and see if you are getting. So you can use these two formulas, calculate, and see if the H you got in the lab is the same as the calculated H here. Okay. Now another example. Here, the sphere, the metal ball, here is 15 centimeters, and that is the diameter. I keep on underlining it to show you, because if you are reading it, you want to uh, put out the important bits. Okay, so you want the radius. The formula hasn't got a diameter, it has the radius. So half of this will be 7.5 centimeters. The beaker here is 70 centimeters as the diameter. So half of this is 35. So in the volume part of the sphere, I'm going to put in 7.5 here, cube it, put it in this formula, 4 over 3 pi r squared. In the cylinder side, I'm going to put 35 all squared in pi r squared h. Okay, because we want, this is the volume of the cylinder formula, and that is the volume of the sphere formula. Now this pi will cancel out this pi. Okay, so now we have 4 over 3, 7.5 cube, which will be equal to 35 all squared h. Now 35 all squared can come and divide here, and then we can find h. So h will be equal to 4 times 7.5 cube, all divided by 3 times 35 all squared. Okay. So if you do that nicely on the calculator, you have checked, so you can also check. So this is divided by a. So the numerator is 1687.6. The denominator is 3675. Okay, 367.5. So that is if you multiply 4 by 7.5 cube divided by 3 times 35 squared. Okay, in the end, you should get 0.46 centimeters to 2 decimal places. Okay, so this is one of the questions that you can get in the higher paper, that if you can remember the formulas, these two important formulas, the volume of the sphere and the volume of the cylinder, then you'll be left stranded. Okay, but you can always, as I said, we've done this volume of the sphere. Okay, and that's the volume of the cylinder. Okay, so as you update your flashcard, especially assuming you are in year 10 now, you update your flashcard, and you have a whole year to use this and to practice some of these questions for you to understand. So immediately you go to the exam room and you have these questions, you can easily use it, because you want to find the rise in the liquid level in the cylinder. It's okay. Please, thank you for subscribing. Help share, okay, invite other people to subscribe as well. Um, if the account is not yours, ask permission from the account holder. Uh, please follow my notes/script. It's very important, especially today. I've just drawn the one diagram from the beginning to explain, okay, and I've shown you the formula we've been using today. Okay, I've brought a, like 3 or 4 examples, and then I've linked it to some of the uh, one of the physics experiments you might do. Okay, so thank you very much for watching today's video with me, and I'll see you in the next.